Hey Transmath class, here are the notes for section 2.13. First of all, we're going to start with doing some inequalities. We're going to put in an inequality symbol to compare each fraction. So we want to decide if we have greater than or less than. Number 1, we've got 9 over 9, which we know is equal to 1, compared to 3 over 2. Now since 3 is bigger than 2, this has to be the larger fraction. So 9 over 9, which is 1, has to be less than 3 over 2, because that's more than 1. Number 2, this one's a pretty easy comparison because they have the same denominator. 1/6 is definitely less than 8/6. All right, number 3, we have 2/3, which is less than 1, compared to 3 over 2, which is more than 1. So this would 2/3 is less than 3 over 2. We have a similar situation here. We're comparing. We're comparing 7 over 6 to 6 over 7. So 7 over 6 greater than 1, 6 over 7 is less than 1, so this would have to be greater than. Okay, and then number 5, 4 over 4, which is equal to 1, and then 8 over 4. Well, 8 is bigger than 4, so that's bigger than 1, so this would be 4 over 4 is less than 8 over 4. Okay, so it says solve the addition and subtraction problems and then tell whether the answer is proper or improper. So recall, improper is when the numerator is either larger than or equal to the denominator. So 5/4 is an example of an improper. Okay, so for number 1, we have 11/5 minus 5/5. So 11 minus 5 is 6. 6/5. 6 is bigger than 5, so I'm going to say improper. I'm just going to put an I for improper. Number 2, 3/8 plus 1/8. Well, we just add the 3 plus 1 and we get 4. So 4/8. Now that one's going to be proper. 12/12 minus 1/12. 12 minus 1 is 11, so we get 11/12. 11 smaller than 12, that is proper. Okay, comma in between. Okay, next problem, 18/12 plus 3/12. 18 plus 3 is 21, so we get 21 over 12. 21 is bigger than 12, so that would be improper. And last one here, 4/9 minus 2/9. 4 minus 2 is 2, so 2/9. 2 is less than 9, so that is a proper fraction. These were all pretty easy because they had common denominators already. All right, so it says adding 3 fractions, so that's what we're going to look at now today. So we may have to find common denominators for 3 numbers. Okay. Here they're just giving you a kind of a visual of some common multiple numbers. So it says let's review least common multiples. Look at the following sets of numbers. What do you think the colors represent? Okay, so we have blue circles around 3, 6, 9, 12. So you can see those are multiples of 3. And then when you see the yellow circles, 6, 12, 18, 24, those are counting by 6s. So those are multiples of 6s. Now look here, we've got 15 and 30. You know, that's of red circles, so you can kind of see those are, and then we start down here with these red circles, 5, 10, 15, 20, 25, 30, 35. You can probably see there we've got, multiples of 5. All right. How do we find the least common multiple for the denominators of 3 fractions? Okay. Well, it says we might think it's easiest to just multiply all 3 denominators together, like if we have a 5, a 4, and a 10. But sometimes you get a really big multiple then that it is a common multiple, but it's not the least common multiple. So we're going to try finding a smaller common denominator when we do this. Okay, so if you have your multiplication table, and many of you have gotten one from me, and I can hand out more if you don't have one. Sometimes that's the easiest way to do it. So you look across your fives row, you look across your 4s row and your 10s, and you'll notice that 20 appears in all 3 of those number multipliers. So 20 is a common multiple of all 3 of those numbers, and that is the least common multiple. There's nothing smaller than 20 that appears in all 3 of these number lines. So then what we want to do is just use 20 as our common denominator. Okay, and once we do that, then we can add those together. So here, 3, 6, and 4. So if we look in each of those rows, we're going to see that a 12 appears in there. So we would want to make a common denominator of 12 when we add those fractions together. Okay, so let's see if we can do this. So if I was looking at 6, 9, and 3. If I were counting by 6s, I'd get 6, 12, 18. If I was counting by 9s, I'd get 9, 18. And if I was counting by 3s, I'd get 3, 6, 9, 12, 15, and then 18. So 18 is going to be your common multiple there. Okay, so we're going to rewrite these. We want to make 18s for each. Okay, so if I have 1/6, I could multiply times 3, which would give me 3/18. Okay, now with the 9 in the bottom, I'd have to multiply by 2, top and bottom, and so that would give me 2/18. And then for the 2/3, I'd have to multiply the 3 by 6, and so that would give me 12/18. Okay, 3 plus 2 is 5, and 5 plus 12 is 17. So we'd get 17/18 for that one. All right, 4, 2, and 3. Okay, I think they gave us that example back here with, maybe it wasn't 4, 2, and 3. But let's just think about this. So if we were counting by 4s, we would get 4 and then 8 and then 12. Well, 8 is a multiple of 2, but it's not a multiple of 3. So I went up to 12. Let's see if we can get 12 with each of these. If we go 2, 4, 6, 8, 10, 12, yes. And how about 3, 6, 9, 12? Okay, so 12 is our common multiple. So if I go times 3 on this one, I get 9/12. If I go times 6, I get 6/12. And if I go times 4/4 here, I'm going to get 4/12. And when I add those up, 15 plus 4, I get 19/12 there. Okay. All right, 4, 6, and 8. So if you were to pull out a multiplication table, I think you would find that 24 appears for each of those numbers in there as a multiple. So I'm going to go times 6 to get a 24. 6/24 here. I'm going to go times 4. So I'm going to have 12/24. And times 3 here, I'll get 3/24. So I've got 6 plus 12, that's 18, plus 3, that's 21. 21/24. All right. 4, 5, and 2. Okay, well, 4 and 5, least common multiple of those is 20. 20 is also a multiple of 2, so that works. So we're going to change them to 20s times 5 here. So we're going to have 5/20. We're going to go times 4. And so we're going to have 4/20 and times 10. And so there we're going to have 10/20. 5 plus 4 is 9, plus 10 is 19. 19/20. Okay, so that's finding common denominators that have 3 fractions. Okay, so word problem here. It says scatter plots are done repairing the floor. Now they are moving onto the plumbing. The pipes in the house are different sizes because of what they transport. Some pipes transport water, some transport gas for cooking and heating. Smaller pipes are used for the gas. Different size pipes are used for the dishwasher, washing machine, and the sink. Okay, so the widths of the pipes are shown below here. The width of a pipe is measured across its widest part or the diameter. So we've got a 1 inch, or I guess it says 1 unit. 1 unit, 3/4 unit, and 5/8 unit. And okay, so we've got, they just tell us what they're for. Washing machine, toilet, dishwasher. The sink is 1/2, and the gas for the stove is 1/4. Okay. So Enrico's measuring the different pipes to see how they're different in width. He's wondering if it really makes a difference what pipe to use to connect the dishwasher or to the toilet. He doesn't know that the smallest difference in width could mean that the pipe could come loose and make a mess. There could be water all over. Help Enrico figure out the difference between the pipe widths. Okay, so we're looking for some differences here, and here we're going to ask specifically which ones. Okay, how much wider is the dishwasher pipe than the sink pipe? Okay, dishwasher, let's go and look again. So dishwasher is 5/8, and the sink is 1/2. 5/8 and 1/2. Now many of these they're saying how much wider, what's the difference. Those are all subtract problems. Okay, so we've got 5/8 for the dishwasher, and I think it was 1/2. Yeah, 1/2 for the sink. Okay, So I have an 8 and a 2. I need to make a common denominator of 8. So then it's going to be 5/8 minus 4/8, and that's going to give me 1/8. Okay, next one. What's the difference between the washing machine pipe and the dishwasher pipe? Okay, well, the dishwasher was 5/8. I remember that from the last problem. What was the washing machine? That was 1 unit here. Oops, 1 unit. Okay. Okay, so I'm going to take 1 minus 5/8. Now 1, technically, it doesn't really look like a fraction, right? But because I have an 8 in the bottom and I want that, remember, anything that has the same top and bottom number, that's going to be equivalent to 1. So, 1 could be anything over itself, and because the 8 is the denominator, I want to say 8/8. If I was subtracting 1/2, I would have said it was 2/2, so that I had the same denominator. But since this fraction had eighths, we're going to call 1 8/8. So 8 minus 5 is 3, and we keep our 8 there. 3/8 is the difference. So Enrico tried to fit the sink on the toilet. It wouldn't fit. How much narrower is the sink? That means smaller, right? Narrower means smaller. Is the sink pipe than the toilet pipe? Okay, so we want to do sink versus toilet. Okay, so sink is 1/2. Toilet is 3/4. So 3/4 minus 1/2. 3/4 minus 1/2. And we're going to go times 2 to make a common denominator of 4. And so it'll be 3/4 minus 2/4. 3 minus 2 is 1. So we get 1/4. All right. And the next one, exactly how much wider is the toilet than the gas pipe? All right, so let's look here. Toilet versus gas. So that's 3/4 and 1/4. Okay, so 3/4 minus 1/4. 3/4 minus 1/4. And I already have a common denominator, so just subtract the numerators, so I get 2/4 for that one. Okay, so that's it. That's our lesson.